this section, we're going to do a review of factoring and solving equations by factoring. The most important thing you can remember from this section is that we always want to look for the greatest common factor first. This is extremely important. Not only is it the best way to proceed, but it also makes your work easier if you see that greatest common factor. Just as an example, in these two here, each one of these problems has something in common. The first one has a 2 in common. All of the numbers are even. So I could factor a 2 out of each one of these before starting. Now, even though this is factored, it isn't factored what we call completely. To factor it completely, you'll need to take the remaining trinomial listed here and factor it. Notice how I'm still leaving the 2 in the problem. Two numbers that multiply together to give me 5, but add up to be 6, would be 5 and 1. So x plus 5, x plus 1. That's the complete factorization. This second, really the only thing that's in common when we first get started is a 4. By taking a 4 out, I get x squared minus 9. Looks like it's done. However, this x squared minus 9 is something special. We called this a difference of squares. So I can continue on, leaving the 4 in front. Difference of squares turns this into an a plus b, a minus b. So again, taking out that greatest common factor first is extremely important, and we should look for that in every single problem that we do. Okay, let's try to review here some solving equations by factoring. You've seen things like this before, but now we're putting them all together. Best thing to do is to move everything to one side. Having that 0 on one side gives me a potential for using the zero product property. Do you see anything in common? There's that x in both of them. So I'm going to factor out an x. Each one of these factors could potentially be 0. So I'm going to set x equal to 0 and the x minus 25 equal to 0. It means we'll have two solutions. One of them will be 0 and the other 25. For this problem, I'm looking for the greatest common factor. There's an x in common. After taking the x out, we're still not done. The remaining binomial is actually a difference of squares. I can write it as a plus b, a minus b. Notice how I left that x, the original x, in the problem. It potentially could also equal 0. So I'm going to have three solutions, either the x equals 0, x plus 6 equals 0, or x minus 6 equals 0. With some quick algebra, I have three solutions. I want to emphasize that whole thing with factoring out the greatest common factor is so important. Has to be done first. For this problem, there's nothing in common when we start. Instead, I'll have to factor the trinomial. I'm looking for two numbers that multiply together to give me negative 30, but add up to be this negative 13 here in the middle. I'll try a couple. Negative 30 and 1, 30 and negative 1, negative 10 and 3, 10 and negative 3, 15 and negative 2, negative 15 and 2, and there it is. So I'm not going to go any further. I'll rewrite the problem now, but instead of writing negative 13, I'll put negative 15x plus 2x in its place. This is going to set up factoring by grouping, looking for what's in common between these two separate groups. The first group has a 5x in common. The second group really has nothing in common. So just to help, I'm going to go ahead and put a 1 out front. You should notice that both of these factors are now 2x minus 3's. That's good. That means I can factor that out. And I'll have 5x plus 1 left over. That's the complete factorization. Now set each one equal to 0 to finish it. With some algebra in the first one, I find one solution is 3/2. In the second one, I find it's -1/5. This is a lengthy problem, but the same factoring that we've done before. Here's an interesting one that's already factored. The problem is I don't have a 0 on the right side. So basically, I'm going to have to expand this and start from scratch. I'm going to FOIL on the left. And then combine like terms. If I'd start factoring from here, I'd be right back to where I started from. Instead, I'm going to move this 40 over to the other side. It'll come over as a -40 or a -36. Now I can start the process. There's a 0 on the right, just like I need. I need to think of two numbers that'll multiply together to give me -36, but add up to be +5. That'll be positive. If I take this 2 out first, this problem will be a lot easier. Now all I have to think about is two numbers that multiply together to give me -20 and add up to 8. Not as difficult. 0. 2 equals 0. That doesn't make sense. To finish this up, I'm going to set each one of these factors equal to 0, and then do some quick algebra to show that the two other solutions are n equals -10 and n equals 2. This has been a great review of all of the things we've done with factoring and actually problem solving. It's been great to use as a review for the test as well.